Let's take the property of equilateral triangles. We know in an equilateral triangle, all the angles are equal. Not only that, all the sides are also equal. Okay, but now we will take all the angles are equal. Look at this figure. Its sides are all equal. That is AB equal to BC equal to CA. What do you mean by that? The distance between AB, this length, and this length, all the three are equal. Since this length and this length are equal, by rule of the isosceles triangle, we know this angle and this angle is also equal. Okay. Same way, if we see this length and this length are equal, angle A and angle B are equal. These two are equal. That is what mentioned here. You can see angle A is angle B, BC, and since BC and AC are equal. From this we found angle C equal to angle A equal to angle B. That means all these three angles are equal. Right? We found that A, B, C, this guy, this portion, all these angles are equal. Hence, in an equilateral triangle, all angles are equal. This is the property we want to prove, right? Okay. All angles are equal. Further, another important property, since all the angles of an equilateral triangle is equal, we know the property that all the angles sum up to 180 degrees. To sum all the three angles, angle A, angle B, and angle C, it should be 180 degrees. That is the property of triangles. Since in equilateral triangle, all these three angles are going to be equal, we have to divide what? 180. We can equally divide the angle among three, right? Then we get what? 60 degrees, right? 3 6 times 30, right? So we give angle A is 60, angle B is 60, and angle C is 60. That is what is mentioned here. In an equilateral triangle, all sides are equal, all angles are equal, and if all the angles are equal, all sides are equal. We can have, you can say either way. Okay. And each angle of any equilateral triangle is equal to how much? 60 degree in an equilateral triangle. Okay. But the lengths of the sides of different equilateral triangles may be different. What we mean by that? In this example you can see we have three examples here. One is 3 centimeter, 3 centimeter, 3 centimeter. Here is 5, 5, 5. Likewise we got 3. Okay. On all the three triangles, you can observe that all the angles are only 60 degrees. The lengths may be different in all the three cases, okay? But they should be same. If so, then the angles would be 60 degrees. The angles would be same, equal. This is called equilateral triangle. Here is an example. In example 5, there is a triangle ABC. In a triangle ABC, angle A is 60 degree, AB equal to AC. What can you say about the triangle ABC? You should learn to construct your own triangle, right? So they said AB equal to AC, and then the triangle is ABC. First, you have to draw a triangle, okay? A, B are equal. So this guy and this guy are equal. So just name a triangle, like to draw two lines. Then connect these two lines. Since AB and AC are equal, we call it this thing. This is going to be 60 degrees. He has given the angle is 60 degrees. So this, we should draw our own triangle, right? So we found this one. If this is 60 degrees, then what do you say about this triangle? This is the question. What do you say? What kind of a triangle it is? What type of a triangle is it? Is it isosceles triangle or is it equilateral triangle? In isosceles, these two sides are equal. Yes, it satisfies the isosceles triangle rule. But we don't know about this side, whether it is equal or not. That is what we are going to find. AB equal to AC, therefore the angle opposite to AB and AC are equal. Since these two are equal, angle C and angle B are also equal. Assuming it is an isosceles, this triangle, this angle and this angle should be equal. Okay, we don't know whether it is equilateral triangle or not now. Okay, we are going to find. Be slow. Since this is equal, these sides are equal, rule this angle should be equal. We don't know what it is. But we know the rule. What? Sum of all the angles is what? This plus this plus this is what? Adding these three is 180 degrees. But these two are equal. So, we got this rule. Remember this? Okay. We know that angle A plus angle B equal to this angle and this angle is equal to 180 degree minus angle A, because subtracting angle A on both sides we get this. How do you write? So this is equal to what? We can come to this thing 180 minus, we know angle A. Now we know angle A. This is 60 degrees. When we subtract this, we are left out with 120 degrees. So angle B equal to angle C. So since angle B and angle C are equal, 120 divided by 2 is how much? So to be 60 degrees. So we have to add equally this one. Now all these angles are equal, then all the sides should be equal per the property of equilateral triangle, right? Hence, if angles are equal, the sides are going to be equal. So we can say BC is also equal to AB. That is equal to AC. That is this and this are equal. Sides and angle, the angle is going to be 60 degree. Then this type of angle triangle is equilateral triangle. That is what's told in the book. Same thing. That is what we calculated here. We divided here, and hence angle is 60 degrees. Since all the angles are equal, all the sides are also equal, and the triangle is an equilateral triangle. You have to note, here is one special note here. Any triangle ABC, the sides opposite to the vertices ABC are denoted by ABC. Okay, this is the notation how we debate, right? If there is a triangle like this ABC, right? This side, the length of this side opposite to this B is mentioned in small letter as B. Opposite to A is mentioned as A. The side opposite to C is mentioned as C. This is the notation you should remember. Next time we won't talk about length BA, BC and all. BA is equal to what? It's equal to C. AC equal to what? Side length equal to what? Opposite to B, right? It will be mentioned as B. BC is what? Opposite to A, right? We call it as A. Remember, this is the notation we have to remember in the future.